So last time we talked about inside angles. So here we're going to talk about outside angles. Now there's different kinds that we can have. So we can have two secant lines, we can have a secant and a tangent, or we can have two tangent. But regardless, even though they all look different, we're all going to approach them the same. So here, the first one, if I'm looking at that outside angle, which we'll call angle A, it's going to create two arcs. This arc out here, which we will call the big arc, and this inside smaller arc, which we will call our small arc. Okay, and if we look at the secant and the tangent, so here's our outside angle, and it's also going to create a what we're going to call a big arc, and it's also going to create this inside smaller arc, which we will call small arc. And the same for the two tangents. So two tangents is still going to create this what we call big arc, and it's also going to create this smaller arc, which we will call small arc, right? And so for regardless of which one you're looking at, or regardless of which one you're doing, when we're looking for the measurement of that outside angle A, it's always going to be half of the difference between the big arc minus the small arc. Now here, order does matter because we want to end up with a positive number. So we're going to subtract the small one from the big one, and not the other way around, because we will get negative numbers. Okay. So here's some practice problems. So looking at the first problem, it says the measurement of angle KLM is what we're looking for, which is there. And so the first thing we're going to do is we're going to identify our big arc and our small arc. So here is our big arc, and here is our small arc. And so to find the measurement of angle KLM, we are simply going to set it up exactly how we had. So the measurement of angle KLM is going to equal half of the big arc, which is 140, minus the small arc, which is 66. And so from here, all we're going to do is simplify each time. So we're going to take half, and then 140 minus 66 is 74. And so here we get that the measurement of angle KLM is going to equal 37 degrees. Looking at the second triangle, we always start kind of the same. Identify the big arc. Now, in this case, my big arc, we're not given. And that's exactly actually what we're looking for, right? So since we're looking for that, we're going to go ahead and call that X. The second thing we're going to identify is our smaller arc, or our small arc. And then they're giving us that outside angle. And so we're still going to approach it exactly the same way with the same formula. So here we have 40 is equal to 1/2 the big arc, which we're calling X, minus a small arc, which is 75. And then we're going to solve for X. So anytime that you can take half of something, go ahead and take half of something. Now in this case, I can't really take half of an X or half of 75 because I'll be dealing with fractions. In that case, I'm going to go ahead and get rid of the 1/2 by multiplying both sides by 2. On the left side, 2 times 40, we get 80. On the right side, we got rid of the 1/2, so we're left with X minus 75. And so for here to solve for X, which X represents the arc SW, we're going to go ahead and add 75 to both sides, and we get X equals to 155. But since X represents the arc SW, then the measurement of SW is equal to 155 degrees. Looking at the last one. So they're asking, we have to be a little bit careful because they're asking for arc EF. Arc EF is actually right there, which is not either the big arc or the little arc. But we're still going to identify our big arc and our small arc. Now here we're gonna have to figure out what is the small arc first, because that's the only one we can calculate. Once we know what the small arc is, then we add the small arc and the big arc, and we're gonna subtract that from 360 to give us the measurement of arc EF. And so we start with 77 is equal to half of half of the big arc, which is 191, minus the small arc, which we're gonna call X. And from here, it's just a matter of solving for X. And again, if you can take half, take half. If not, we're going to go ahead and multiply both sides by 2 to get rid of the half. On the left side, 77 times 2 gives us 154. On the right side, we got rid of the half, and we're left with 191 minus X. So when I subtract 191 from both sides, on the left side, I'm left with negative 37. On the right side, I'm left with negative X. Now, since they're both negative, we can go ahead and either multiply by -1 or divide by -1. But either way, I end up with X equals 37. Now, remember, X here represents the small arc. So that small arc is actually 37. So from here, what we're going to do is we're going to take 360 degrees, which is the full circle, and we are going to subtract 191, which is the big arc, minus the small arc, which is 37, and that's going to give us the arc measure of EF, which in this case, the arc measure of EF is going to equal to 132 degrees.